Welcome to Cosmic Compass, the place where we explore the wonders of the universe together, from the planets and moons of our solar system to the most mysterious objects at the edge of space. We uncover the stories that science reveals about our cosmic neighbourhood. Today we're travelling far beyond the familiar worlds, all the way to Neptune's realm. There are strange moon orbits in defiance of the rules a captured wanderer that may hide oceans, volcanoes, and even the ingredients for life. This is the story of Triton, one of the most extraordinary moons in the solar system. Imagine a moon that defies nearly every expectation we have about natural satellites. It moves against the rotation of its planet, it may hide a vast ocean beneath its frozen crust, and it is scarred by geysers and ice volcanoes that reshape its face. This is Triton Neptune's largest and strangest moon, and one of the most fascinating worlds in the solar system. Yet Triton is also easy to forget. It orbits the most distant planet from us. Neptune and humanity has only glimpsed it once during the fleeting Voyager 2 flyby in 1989. That single encounter revealed a world unlike any other, and since then astronomers have pieced together more of Triton's story. So today, let's journey together across 4.5 billion kilometres of space and uncover everything we know about this captured world on the edge of the solar system. Triton is one of 14 known moons of Neptune, but it immediately stands apart from the rest. While Neptune's inner moons follow neat circular orbits close to the planet's equator, Triton breaks all the rules. It circles Neptune in a retrograde direction, meaning it orbits clockwise, while Neptune itself spins counterclockwise. Even more unusual, its orbit is tilted at a steep 130 degrees compared to Neptune's equator. In other words, Triton does not follow the natural path of a moon that formed alongside its planet. And yet, despite this odd tilt and retrograde motion, Triton's orbit is nearly perfectly circular. That alone makes it unique among large moons in the solar system. All other spherical moons orbit prograde in the same direction as their planets spin. This strongly suggests that Triton was not born around Neptune at all. Instead, it must have been captured, pulled from a different part of the solar system, and bound forever as Neptune's largest satellite. But how does a capture like this happen? Normally, an object with too much momentum would simply swing past a planet and continue on its way. To be captured, it has to lose speed. The leading theory is that Triton was once part of a binary system, much like Pluto and Charon. When Neptune encountered this pair, its gravity tore the two apart. One object was flung into interplanetary space, while the other, Triton, was slowed just enough to fall into orbit around Neptune. This violent cosmic theft explains why Triton is so unlike the planet's other moons. In fact, it is not only the largest of Neptune's satellites, it also dominates the system by mass, accounting for 99.5% of everything orbiting the planet. In a sense, Triton is less a moon and more a captured dwarf planet. So how big is Triton really? It is smaller than Earth's moon, but because it orbits closer to Neptune, it would appear roughly the same size in the sky if you were standing on the planet's surface. Triton is the 7th largest moon in the solar system, but here's what makes it striking. It is bigger than Pluto, the object often called the king of the Kuiper Belt. That means before Neptune stole it, Triton itself may have been the true ruler of that distant region. When the New Horizons spacecraft visited Pluto in 2015, it revealed a world with striking similarities to Triton, from surface composition to geology. This is powerful evidence that both worlds share a common origin, icy bodies born in the Kuiper Belt, separated only by fate. What would you see if you could walk across Triton? At first glance, the surface looks smooth and strangely youthful. Unlike most moons littered with craters, Triton's face is largely unscarred evidence that it is constantly renewed. The crust is made mostly of frozen nitrogen mixed with water ice and carbon dioxide ice. Voyager 2 showed us plains, ridges, plateaus and troughs, but almost no impact craters. In fact, Triton's topography varies by less than a kilometre across vast regions, giving it a strangely uniform landscape. Here and there, reddish patches break the monotony. These are thought to be deposits of methane ice that reacted with sunlight, forming tholins, organic compounds with a tar-like texture. While organics do not mean life exists, they are the chemical building blocks that life requires. On the surface, Triton is far too cold and dark for anything to survive, but the story beneath the crust is far more intriguing. Inside Triton lies a rocky and metallic core that gives it a relatively high density of about 2 grams per cubic centimetre. Radioactive decay from this core could provide enough heat to maintain a layer of liquid water beneath the icy crust. This puts Triton in the same category as Europa and Enceladus worlds, where hidden oceans might exist under the ice. The possibility that water, heat, and organic compounds could interact makes Triton one of the most promising places in the solar system for conditions that might support life. Think about it, a captured dwarf planet dragged into orbit around Neptune, still carrying the ingredients for habitability deep inside. It's an extraordinary scenario. Triton is not just frozen and quiet, it is alive with geological processes. Voyager 2 revealed evidence of cryovolcanoes, eruptions of water and other ices that reshape the surface. Some plains appear to be frozen lava lakes of water ice called planitia. Calderas mark the collapsed centres of cryovolcanoes. Dark streaks across the landscape trace the deposits of past eruptions, some stretching for hundreds of kilometres. These eruptions could even bring materials from the subsurface ocean onto the surface, spreading organics across the icy plains. This is why Triton's surface looks so young. It is being renewed by ongoing activity, not left to grow old and cratered. One of the most dramatic discoveries from Voyager 2 was Triton's towering plumes. Some of these eruptions reached 8 kilometres into the sky, but curiously they may not come directly from the interior. Instead, they might be caused by what scientists call a solid greenhouse effect. Picture a thin sheet of clear ice resting on darker material beneath. Sunlight passes through the ice, warms the darker surface, and causes nitrogen ice to sublimate into gas. As pressure builds, the surface eventually cracks and explodes outward, sending geysers of gas and dust into the sky. It's an extraordinary process, one that has also been observed on Mars's polar caps. On Triton, it shows us that even with little sunlight and an extremely thin atmosphere, dramatic geological activity is still possible. Triton's atmosphere is thin, just 0.4 millibars, the equivalent of standing 80 kilometres above Earth's surface, and yet, despite being so tenuous, it supports clouds, winds, and haze. When Voyager 2 flew past in 1989, it captured images of faint clouds and plumes, all bent in the same direction by prevailing winds. Later, observations showed the atmosphere has grown denser, likely because of seasonal warming and the slow evaporation of surface ices. Like Pluto, Triton's atmosphere is laced with hydrocarbons that create a hazy veil. This haze, combined with cryovolcanism and seasonal changes, makes Triton an active and evolving world. It is far more dynamic than most moons in the solar system. So what is Triton really? It is a captured world, a former dwarf planet, once free in the Kuiper Belt, now enslaved by Neptune's gravity. It is larger than Pluto, more active than many moons, and it holds secrets deep below its icy crust, with geysers, cryovolcanoes, a thin atmosphere, and perhaps even a hidden ocean. Triton blurs the line between moon and planet. It may be one of the most unusual and promising places to search for life beyond Earth, and that's why Triton should not be forgotten. It is a reminder that even in the coldest, farthest reaches of the solar system, worlds can surprise us, challenge us, and perhaps even harbour the ingredients for life. If you enjoyed learning about Triton, there's so much more waiting to be discovered. Our universe is full of hidden stories, and each world has secrets worth exploring. Don't forget to like this video, subscribe to Cosmic Compass, and turn on notifications so you won't miss our next journey. You can also check out our other episodes on the planets, moons, and cosmic phenomena that shape our solar system. Thank you for watching, and until next time, let's keep exploring the cosmos together.